Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner.
Let's understand the basic concepts of three-dimensional geometry. In this video, we will discuss some basic concepts of three-dimensional geometry, and the first among them is direction angles. Suppose line L is any line in space. The angles made by the line L with the positive directions of x, y and z axis are called the direction angles. Let ray OP is parallel line L. The angles made by ray OP with the positive x, y and z directions will be the same as that made by the line L with the positive x, y and z directions. If the angles made by line L with the positive direction of x-axis is alpha, which is this, y-axis is beta, which is this, and z-axis is gamma, which is this, then alpha, beta and gamma are called the direction angles of the line L. Next is direction cosines. Cosines of the direction angles of a line L are called direction cosines. They are denoted by letters L, M and N. So, L equals cos alpha, M equals cos beta and N equals cos gamma. The direction cosines are unique for a given line in space. For this line L, its direction cosines will be unique. Now we will understand one important result of the direction cosines. If L, M and N are the direction cosines, then we have L square plus M square plus N square equals 1. We will prove this result. Let line L in space has, this is line L, which has direction cosines L, M and N. Let point P, X, Y, Z be on the line L, this point. Its position vector will be OP bar equals xi cap plus yj cap plus zk cap, and magnitude of OP bar will be R. Consider dot product OP bar dot I cap, which will be xi cap plus yj cap plus zk cap dot I cap. We write I cap as I cap plus 0j cap plus 0k cap, which will be x multiplied by 1, y multiplied by 0 and z multiplied by 0. So that gives us OP bar dot I cap equals x. Also, by the definition of dot product, we have OP bar dot I cap equals R, which is the magnitude of OP bar, and 1, which is the magnitude of the unit vector I cap cos alpha. We get OP bar dot I cap equals R cos alpha. X equals R cos alpha. Therefore, we write X equals R cos alpha. On the same lines, we can prove that Y equals R cos beta and Z equals R cos gamma. We got OP bar equals X I cap plus Y j cap plus Z k cap, which will be R cos alpha I cap because X is R cos alpha, R cos beta j cap because Y is R cos beta, plus R cos gamma k cap because Z is R cos gamma. Now we will take self dot product of OP bar and write OP bar dot OP bar, which will be mod OP bar square cos 0 because the angle between the self vectors will be 0 degrees, so which will be mod OP bar square. So we write this self dot product as this is OP bar and this again is OP bar, which will be R square because mod OP bar is R. Now the dot product of OP bar and OP bar will be R cos alpha whole square plus R cos beta whole square plus R cos gamma whole square, which will be R square. So that will be R square cos square alpha plus R square cos square beta plus R square cos square gamma equals R square. We will take R square as the common factor and write R square times cos square alpha plus cos square beta plus cos square gamma equals R square. R square from both sides gets cancelled and we get cos square alpha plus cos square beta plus cos square gamma equals 1, or in other words L square plus M square plus N square equals 1, and this is what we have to prove. The next concept is called direction ratios. The real numbers proportional to the direction cosines are called direction ratios. If A, B, C are real numbers and L, M, N are direction cosines of a line such that A by L equals B by M equals C by N, then A, B, C are called direction ratios. There is a definite relationship between the direction cosines L, M, N and the direction ratios A, B, C of a line, and these relationships are L equals plus minus A by square root of A squared plus B squared plus C squared. M is plus minus B by square root A squared plus B squared plus C squared, and N is plus minus C by square root A squared plus B squared plus C squared. We will evolve some more important relationships. The first among them is if L, M, N are direction cosines of a line and R cap equals L I cap plus M j cap plus N k cap is a unit vector along the line, then R cap equals R bar by mod R bar. That gives us vector R bar equals mod R bar times R cap. So we get the relationship r bar equals mod r bar L I cap plus mj cap plus nk cap. There is one more relationship. If r bar equals ai cap plus bj cap plus ck cap is a vector having direction ratios a, b, c and direction cosines L, M, N, then mod r bar will be square root a squared plus b squared plus c squared, and from the relationship L equals plus minus a by square root a squared plus b squared plus c squared, we write a equals L times square root a squared plus b squared plus c squared. So we get a equals L times mod r bar, and on the same lines we can get two more relationships. B equals m times mod r bar and c equals n times mod r bar. For a point P, X, Y, Z, on the line L with direction cosines L, M and N, if mod OP bar equals R, then x coordinate of P will be LR, its y coordinate will be MR and z coordinate will be NR. So we get the coordinates of P as LR, MR, NR. These coordinates x, y, z become LR, MR, NR. We will solve some representative problems based on the concepts that we have just understood. In question number 1, if a line makes angles 90 degrees, 60 degrees, 30 degrees with the positive directions of x, y and z axis, we have to find its direction cosines. The direction angles given are alpha equals 90 degrees, beta equals 60 degrees and gamma equals 30 degrees. So the direction cosines of the line will be cos 90 degrees, that is 0, cos 60 degrees, that is half, and cos 30 degrees, that will be root 3 by 2. So these are the direction cosines, 0, half and root 3 by 2. The second question is similar to the first one. If a line has direction angles 90 degrees, 135 degrees and 45 degrees, then we have to find its direction cosines. The direction angles are alpha is 90 degrees, beta is 135 degrees, gamma is 45 degrees. So the direction cosines of the lines will be cos 90 degrees, which is 0, cos 135 degrees will be cos of 90 plus 45, which will be minus sine of 45 degrees. Cos 135 degrees will be minus 1 by root 2. Cos 45 degrees is 1 by root 2. Hence, the direction cosines of the lines will be 0, minus 1 by root 2 and 1 by root 2. Question number 3 is, if a line has direction ratios 4, minus 12, 18, then find its direction cosines. The direction ratios are 4, minus 12, 18. Therefore, its direction cosines will be L equals 4 by square root 4 squared plus minus 12 squared plus 18 squared, which will be 4 by square root 16 plus 144 plus 324, which will be 4 by square root of 484. That will be 4 by 22. That is 2 by 11. So L will be 2 by 11. M will be minus 12 by square root 4 squared plus minus 12 squared plus 18 squared. That will be minus 12 by 22, which will be minus 6 by 11. So M is minus 6 by 11. N will be 18 by square root of 4 squared plus minus 12 squared plus 18 squared, which will be 18 by 12, that is 9 by 11. So the direction cosines of the line will be 2 by 11, minus 6 by 11 and 9 by 11. Let us understand one more property of direction ratios. If a line passes through 2 points x1 y1 z1 and x2 y2 z2, then its direction ratios are A equals x2 minus x1, B equals y2 minus y1, and C equals z2 minus z1. Direction ratios of parallel lines A1 B1 C1 and A2 B2 C2 are proportional, that is A1 by A2 equals B1 by B2 equals C1 by C2. But their direction cosines L1 M1 N1 and L2 M2 N2 are the same, that is L1 equals L2 equals L, M1 equals M2 equals M, and N1 equals N2 equals N. In question 3, we have to show that the 4 points A 5 minus 1 1, B 7 minus 4 7, C 1 minus 6 10, and D minus 1 minus 3 4 are the vertices of a parallelogram. We will find the direction ratios of the opposite sides of this quadrilateral. So first, direction ratios of side AB will be 7 minus 5, minus 4 plus 1, 7 minus 1, that will be 2 minus 3, 6. Direction ratios of DC will be 1 plus 1, minus 6 plus 3, 10 minus 4. That gives us 2 minus 3, 6. Here, since the direction ratios of AB and DC are proportional, we can say that AB is parallel to DC. Side AB is parallel to side DC. Next, we will find direction ratios of side AD, which will be -1, -5, -3, +1, 4, -1. That gives us -6, -2, 3. Direction ratios of BC will be 1, -7, -6 plus 4, 10, -7. That will be -6, -2, 3. Since the direction ratios of AD and BC are proportional, we can say that AD is parallel to BC. Side AD is parallel to side BC. Since the opposite sides of this quadrilateral ABCD are parallel to each other, we can say that ABCD is a parallelogram. In question 4, we have to show that there is no line in space whose direction angles are 30 degrees, 45 degrees, 60 degrees. The direction angles of the line will be alpha equals 30 degrees, beta equals 45 degrees, gamma equals 60 degrees. We will find cos square 30 plus cos square 45 plus cos square 60. Cos 30 is root 3 by 2, square of that cos 45 is 1 by root 3, square of that cos 60 is 1/2, square of that. It will be 3/4, 1/2 and 1/4, which will be 3 by 2, which is not equal to 1. Since the direction angles 30 degree, 45 degree, 60 degrees do not satisfy the condition cos square 30 plus cos square 45 plus cos square 60 equals 1, we can say that there is no line in space whose direction angles are 30 degrees, 45 degrees and 60 degrees. Question 5 is the direction ratios of AB bar are -2 to 1. If A is 415 and mod AB bar is 6 units, then we have to find the coordinates of point B. First, we will find the direction cosines of AB bar. So L will be plus minus -2 upon square root -2 square plus 2 square plus 1 square. That will be plus minus -2 by 3. This will be 4 plus 4, 8, 8 plus 1, 9. Square root of 9 will be 3. M will be plus minus 2 by, which will be plus minus 2 by 3. N will be plus minus 1 by, which will be plus minus 1 by 3. We will assume the coordinates of B to be x, y, z and write the direction ratios of AB bar as x minus 4 equals L times mod AB bar, which will be x equals plus minus -2 by 3 times 6 plus 4. 3 2s are 6, 2 2s are 4, so it will be minus plus 4 plus 4. So that will be either 0 or 8. Y minus 1 will be m times mod AB bar. That will be y equals plus minus 2 by 3 times 6 plus 1. 3 2s are 6, 2 2s are 4, so it will be plus minus 4 plus 1. So that will be either 5 or minus 3. Z minus 5 will be n times mod AB bar. That will be Z equals plus minus 1/3 times 6 plus 5. 3 2s are 6, so it will be plus minus 2 plus 5. So that gives us Z equals 7 or 3. So coordinates of B will be 0, 5, 7, or they will be 8, minus 3, 3. So coordinates of B are 0, 5, 7 or 8, minus 3, 3. In question 6, we have to find the vector of magnitude 9 which is equally inclined to the coordinate axis. Let r bar be the required vector and mod r bar equals 9 units, which is given. Direction angles be alpha, beta and gamma, and alpha equals beta equals gamma is given. So it will be cos alpha equals cos beta equals cos gamma, and we write cos square alpha plus cos square alpha plus cos square alpha equals 1, because cos alpha is same as cos beta is same as cos gamma. So this gives us 3 cos square alpha equals 1, that is cos square alpha equals 1/3, and cos alpha is plus minus 1 by root 3. Now cos alpha equals cos beta equals cos gamma, which will be plus minus 1 by root 3. A unit vector in the direction of r bar will be r cap equals L I cap plus M j cap plus L k cap. But r cap, so that will be r cap equals plus minus 1 by root 3 I cap plus minus 1 by root 3 j cap plus minus 1 by root 3 k cap. But we have r bar equals mod r bar dot r cap. So therefore the required vector r bar will be 9 times plus minus 1 by root 3 I cap plus minus 1 by root 3 j cap plus minus 1 by root 3 k cap. So the required r bar vector will be plus minus 3 root 3, because 9 by root 3 is 3 root 3 times I cap plus j cap plus k cap. So this is the first section of three-dimensional geometry. If you like this video, please click the like button. Don't forget to subscribe this channel to get more videos of this type. Share this video with your friends. Thanks for watching. Keep watching Number Collage. See you in the next video. Thank you.